Good afternoon, everyone, and welcome. Up now, we have Andrew Paul in his talk, The Algorithm That Nearly Killed Me When Testing Isn't Enough.
Thanks very much. Welcome, folks. I kind of need to apologize in advance. I said this on LinkedIn already this week, but this has been something that has been emotional to go through. It's caused me a lot of annoyance and pain going through. And even this morning, I have redrafted it again, just trying to give a professional focus without ranting. So it's maybe not as polished as I would like it, but hopefully you'll bear with me on it. To give you an idea, as a diabetic, because some of you won't be diabetic, you have a scale of things that you have to work on. And one of the things is called an HbA1c. And what that shows is how much blood sugar, or how much sugar has been in your blood in the last 3 months. A normal person has a small amount. Anything more than that, it's going to cause problems. So if you're somewhere on the right of this graph with a number that's 97 or more, big red box, the hospital people are going to hate you. If you're in the orange box, well, actually, they're still not going to like you very much, but at this point, they're lecturing you as to all the problems you're going to have, the feet getting rotten, other things not working, eyesight being damaged, and it's scary and really not good. If you're in the yellow, they're probably not telling you off as much, but you're still not in a great place, but you're getting closer. And once you start to hit the green box, well, actually, they're probably going, good for you. Okay, and I'm telling you this because I want to show you where I am at on this scale in terms of the experience and background that I'm bringing as someone that's been with diabetes for far too long. The light green box, they're coming to you and asking questions. How do you deal with this in your everyday life? Because you're kind of an expert at this point. The guidelines that they're meant to follow are the bottom of the blue box, the NICE guidelines, which says that everything should be less than 48. And frankly, that as a target is ridiculous, because if most people are trying to target that, to get an average sugar that's lower than that, you have to have hypos quite a lot of the time. And that's riskier even than running high, because it's an emergency that's very time critical. If you're in the purple box, other diabetics hate you because your control is so good. And if you're in the gray box, you're actually a normal human being. You're not diabetic at all. That's not exactly true, but it's not far off. To give you an idea of where I'm at last check, I was sitting right on that boundary. My name is Andrew Paul. I'm a software engineering trainer at Instill with 29 years of diabetes under my belt. I've had it from I was 3 years old. And what I want to bring to you today is the experience that I had whenever I decided I was going to turn around and let an algorithm start to look after my diabetes. This is a device that's been brought to market, has been tested, has been proven to work for the majority of people. And what I have found through the experience of going through this is that whilst I no longer have to inject 8, 9, 10 times a day to maintain that level of control, this had an awful impact on me. And a realization, more than what I've been ranting about before, that I think as an industry, we don't test sufficiently. If you don't take anything away today, make sure you take this, if nothing else. Your tests are probably passing right now. But that does not mean that your users are safe. Let me tell you about the 78 hours that proves this is the case. This is the view that you would typically get on an app that runs this kind of pump. It's a closed-loop system. In other words, what we have is a monitor that generally sits on the back of the arm for up to 15 days at a time, and it's constantly taking blood sugars. Saves you pricking your fingers and bleeding yourself. Okay, and it takes these constantly, every couple of minutes. Wonderful piece of technology. Combine that in with the idea of a pump, which delivers insulin. It gets installed temporarily for up to 3 days at a time, and just gives little bits as you need it. Up until now, the two systems didn't talk to each other, so you had to look at the device, decide how much you needed, put it in. The magic of the algorithm says when your blood sugar goes up, I'm going to give you some insulin to bring it down. When your blood sugar goes down, I'm going to stop giving you insulin so that it can start to come back up. There's a huge level of other complexities that are involved, but that's the gist of what we're focusing on today. So this is what we see. So anything inside the blue box means you're in range. We want 90% of our values in range. That means you're a well-controlled diabetic. Here's the laugh of day one starting. This system, we began to get trained on it at 12 o'clock. By 12:30, the training was over. The system hadn't even started to work yet. Worry number 3. That's right, I've skipped 1 and 2. Number 1 was when the trainer turned around and said, okay, we know you're all using your phones. We cannot advise you to turn off automatic system updates on your mobile phone. Wink, wink. Now, as somebody working in it and still a cybersecurity company and a software developer at the same time, alarm bells were going off and I was nearly coming off that call, but I persevered. Alarm number 2. We can advise you to turn off the automatic updates on our app because it's gone wrong in the past. We'll persevere. Problem number 4 is that these set of blood sugars, which are actually outside of range, aren't my blood sugars at all. They come from the simulation data that we had to play with for the week before the course started. Didn't even clear off the system. Anyway, we'll be careful with how much we rant. But what I'm wanting you to see is that this is the target range. Anything above this isn't necessarily emergency straight away, but the longer it stays up there, the worse it gets, and within 24 hours it is an emergency. And anything underneath here is an emergency. It needs to be sorted very quickly. So this is the first couple of hours. They said, trust the algorithm, it takes about a month to learn. So here's day 1. It's not awful. As a diabetic that's been in control, it's not good, but trusting the system's going to work, it's not awful. You can see my blood sugar starting to go up. With this, I'm really not feeling all that great. I'm achy, I'm thirsty, I'm needing the bathroom, I'm slightly headachy. But that's typically what happens when your blood sugar goes slightly up. And they've taken away my normal 24-hour background insulin because I don't need it anymore because the pump delivers 24/7 instead. So I'm going through withdrawal, and at the same time this is happening. So I'm not worried yet. But you can see it's delivering. The pink line is how much insulin it's giving. So you can see 1 to 5 units. It's given 1 unit. It's stopping. As it starts to crawl up, it's starting to give me more insulin to try and deal with it. Quite a sharp uptake, but that's what it's doing. And it's going up and it's coming down. It's cutting out and it's realizing actually it needs to go back up again, and the pattern repeats. But it's getting there. And by day 2, this is the end. Look. Magic. It's nearly in range. Isn't that cool? We should be impressed. It's learning. Ooh. Okay, yeah, there's a couple of blips, but it's learning. That's okay, I can cope with that. I stand at a desk for 8 hours a day. That's a good time to be dropping, just a wee quick sweet, and away we go. Here continues the day, and this is where it starts to go wrong. This is where it started to go up. Of course, before bedtime, because everything happens when you need sleep, doesn't it? Starts to go up, and it just hits the critical danger level of what the pump has outlined. It says if it gets to 15 and it sits here for more than an hour, get help. So I watch it, and it goes up, and look, it's starting to come back down. Now, by this stage, I'm feeling really rubbish. I am aching. I can taste the bitterness starting to come through in my mouth. I'm exhausted, but I can't sleep. But it's starting to come down, and the stress is starting to ease. Just for reference, just to show you that the app is slightly problematic in part of my concern, look at the time on here. So it's 22:19. It says it's currently delivering 0.0 units per hour in automatic mode. Look at the graph and what the graph is claiming on the app where the algorithm lies. The algorithm stays on the phone, not on the pump. 22. close to 3. What we're starting to see here is an algorithm that thinks it's doing a wonderful job, but potentially isn't doing anything at all. And if you think I was feeling awful here, yes, thank you for the expletive, whoever that was. That was what the nurse, when I talked to them later on, said as well. I went to bed that night thinking it was coming down. I woke up in the middle of the night feeling absolutely awful. At this point, what your body does, it sees there's so much sugar in your blood that it can't cope. It needs to get energy from somewhere because it requires insulin to get the sugar into the cells for it to work. So it goes into panic stations. It starts to burn fat, which in our culture, burning fat's good. No, not this way. Because this burning fat produces a thing called a ketone. A ketone, when it gets into the blood, is acidic. Blood plus acid equals very, very sick. You have 12 hours. 12 hours, your kidneys start to shut down. Your brain starts to swell. You go into a coma. And you can guess what comes next. I didn't get there. I got to here, woke up confused because your head doesn't work right, exhausted but couldn't sleep, feeling like I was about to boke. And some instinct from the last 29 years said, go and grab a pen and stick it in you. Draw it up, whacked it in. Boom. Started to feel better. At this point, I'm tired, I'm ill, I'm still not feeling great. So I call for help, as in not emergency help, but the hospital help to give advice. They work 9 to 5. They're not available until certain appointments, but I was under control. Trust the algorithm is the message you get. It will work. It's just a blip. These things happen. So on goes the pump again. Close the loop. Trust it. And bearing in mind I hadn't quite recovered from the last time, other than the sugar was in the range. Look what happens next. Higher than before. Worse than before. My wife, who works in the hospital, I phoned her in the middle of a shift and said, I don't know what to do. And she was borderline calling an ambulance, except I said, no, I think I can do this. Lying on the floor, feeling awful, waiting for, again, the pen to kick in. This is a system that has been tested. The tests have to have passed. This is a system that's been integrated. The integration tests have to have passed. What our problem, I believe, as an industry is that we are getting very, very good at having tests in place, but do they actually test the impact of what's going on? As an engineer, I'd ruled out everything else. I have that instinct not to just blindly trust something. I have the systematic thinking that turns around and says, well, have I checked that the cannula maybe hasn't got blocked? Have I turned around and said, has the insulin overheated and gone bad? I've ruled all those things out. I've changed them all. And all that leaves is the software. And as hopefully you can see from the pictures, you might not trust the software either. We need to think beyond the edge cases. The edge cases here are probably fairly straightforward and rightfully identified. You can imagine that if a blood sugar is less than 4, 4 is the lowest it should be. We can talk about variations later, but less than 4 is the rule. If it's less than 4, don't allow the user or the algorithm to give any insulin. Black and white, that's the edge, done. Edge case number 2. The pump hasn't pumped in the last hour. There's a risk that if there's been nothing going through at all, that actually the little cannula is going to block, and when you do need something, it's not going to work. So every hour, a tiny little amount gets injected. Push 0.1 units, just in case. But here's where I think we go wrong. These are sensible rules. They're easy. But what we don't do is push to the next limit. What happens if it's less than 4 and it hasn't pumped in the last hour? Well, from what you've seen of the graphs, it's probably obvious now, isn't it? If you weren't sure before. The correct answer is don't give insulin because it's less than 4. Here's what my pump does. Less than 4. This might look like a blip. That is 0.1 units being delivered to clear the cannula. But to give you context, for me, 1 unit takes my blood sugar down by 1.5 millimoles. So 0.1 brings it down by nearly 0.2. And I, for having diabetes in over 29 years, am less sensitive to insulin than a lot. Anybody that's new to this game within the last 10 years has probably taken a third of the amount of insulin I have to take, because I'm not fresh. They're not as sensitive. So 0.2 for me could be half or 1 for them. And yet at the moment, the system delivers when low. And that's a bigger emergency than anything I've shown you so far. These are edge cases that haven't been put together. This is what I think as an industry we need to be looking at. It's the edge cases between the edge cases. Sounds stupid when you think of edges, but you get my drift. It's the dangerous space where we have identified independently safe rules, but they can be put together to create these unsafe combinations. And beyond insulin pumps, this is where it maybe matters too. Your payment system might correctly validate credit cards, card numbers, and correctly then apply some sort of currency conversion. But have you tested what happens when someone gets declined halfway through a currency conversion during a network partition? We have 3 possible rules there, 3 possible edge cases that we've managed each on its own, but what happens when they all collide? When the chaos ensues? Or you've got a recommendation algorithm, which quite rightly avoids showing extreme content, but it boosts popular content. Well, what naturally starts to happen there while you don't acknowledge the extreme content is that it naturally aggravates people. People start to comment on it, whether in support or against it. Now it looks more popular, and all of a sudden you're starting to produce radicalized content that's starting to rise because the 2 edge cases combine together. Have we tested these in isolation? And when you start to bring in something that is learning, often learning based on the blinkers that we have put on it, well, yeah, the tests pass, green tick eyes, but actually the problem's going to get exponentially worse. Because it's not just dealing with the rules that we've written for it, it's starting to learn, it's starting to discover patterns that we haven't seen before, but we haven't understood before, patterns that might make perfect sense individually, but whenever we start to bring them together are creating these dangerous interactions that we never properly anticipated. My pump was learning, it was adapting, which is all good. But somewhere in that learning, it started to find patterns. It started to find intersections. And it confidently keeps going in the wrong direction. So how do we protect against that? Traditional testing doesn't catch it. We need to enhance our tests. Integration tests don't catch it. Even most end-to-end tests don't really catch this because we are writing all of these tests based on scenarios that we can imagine from the information we've captured so far. And when we feed it to a robot, what we get are lovely edges that look safe with a thumbs up, and it's entirely ignorant of the exploding volcano behind it. Extend the metaphor as you may. So this is typically what we're going with, okay? Let's be honest about what we actually do. We write unit tests that prove that our functions work, and that's good. We write integration tests, that prove components talk to each other. And that's good. We have some sort of threshold coverage that we hit, 70%, 80%, whatever makes the CI pipeline go green. And that's good. And when all those things are good, we ship it. Green builds, passing tests, high coverage, we feel safe. But feeling safe is not the same as our users being safe. I've ranted about this for dear knows how long now in every training course that I deliver involving some sort of testing and security and best practices. But the systems that we work with don't have to be life critical to cause dangers to our users. Have we forgotten the post office scandal already with Horizon? Hundreds of sub-postmasters whose lives were put on hold, systems destroyed, reputations destroyed, people put in jail, people dragged through court cases, some people even taking their own lives because they couldn't live with the guilt of what they were being falsely accused of. As an industry, were we able to stand up and say, we believe that the testing was good and it wasn't their fault? Or do we quietly hide behind it and say, well, it might happen to us, so let's not challenge them on it? Everyone trusted this system. It looked like they'd stolen money. I'd imagine the tests passed. The system was confident. Until the software was wrong. Not just occasionally wrong, but systematically, catastrophically wrong. And this is what keeps me up at night. And it's got worse when I started in this bump. I bet, or maybe I should hope anyway, that their test coverage was decent. I bet, or I hope, that their builds were green. And I bet, or at least I hope, that they had a QA sign off before it went out there. The problem wasn't that they didn't test. The problem was what they were testing. And they were testing the wrong things. They probably tested transactions processed correctly, but what they didn't test was what happens when the network fails mid-transaction. They probably tested that the audit trail was complete, but they didn't test whether that audit trail could lie. What they were testing, I'd imagine, I've no proof otherwise, was implementation. What they needed to test, and what we all need to test, is impact. And I think it gets worse when you add machine learning into this mix. Because now your system is starting to make decisions based on patterns that it's found in your data, patterns that you might not even understand, well, actually, we have some problems arising. I'm not against it, but we need to be on top of it. Patterns that might be correlations, but they're masquerading causations. Patterns that might be amplifying biases which we didn't even know existed. And then the good old response, but sure it'll learn. It's going to get better itself. Sure. It'll definitely learn, but the question is it going to learn the right thing or is it going to learn the wrong thing? And that's the question. And by the way, my pump really did learn. It took that R72 moment where it turned around and said, you know what, Andrew needs about 6 units of insulin at 12 o'clock during the daytime. And the next day when my blood sugar was 4.5, guess what it did? It started to give me 6 units of insulin because it learned that's what it needed the day before. I'm really sorry, I don't have a screenshot to show that. But that's a faster emergency if you don't know what the symptoms are. And here's what I think is the really uncomfortable truth. We have modern teams, but who's responsible for catching these problems? Rightly, I think we've tried to get rid of the dedicated tester role. We're becoming T-shaped, that's the closest I could get, I'm sorry. T-shaped engineers. where we're handing over the responsibility to everybody. Everybody is now part of the quality. Everybody is now meant to be able to look after it. And that's great in theory. But have we actually trained the team in how to test? We talk about maybe test-driven development. Woohoo! But how many of us still actually test first? We talk about behavioural-driven development. We maybe do write gherkin tests, but how many of us actually write scenarios that capture the user risk rather than just some checklist of acceptance criteria? What has happened is we've distributed the responsibility of testing, but I don't think we've fully distributed the expertise. And now we're going into an era of machine learning and AI, and that expertise is going to disappear into the ether even more. We're now shipping systems that are making the decisions that affect real lives in various ways, and we're testing with the exact same rigor as what we did when the systems were just shuffling about database records in different ways. We've moved on, but has our attitude, our understanding, and our delivery of testing moved on with it? So what are we actually going to do about this? Because I had to stop ranting at some stage. Well, here's 10 things that I feel that we can do on Monday morning. 10 practical strategies that will help us shift from just testing implementation to testing for impact. First of all, create an interaction matrix for your edge cases. It's literally like a spreadsheet. There's maybe other ways that are better. You've got rows of edge cases, columns of edge cases, see where they interact. So you turn around here and you maybe see, okay, fraud flag and rate limit. Your fraud detection maybe is what you have here. It looks and it says there's some suspicious activity and it temporarily blocks the account. Your rate limiting correctly turns around and says, okay, someone's tried to log in maybe 3 times, stop any more. 2 very sensible limits. But most of us have heard of someone, or maybe have been there ourselves, where we're abroad on holiday, you try and access your bank account, it looks suspicious. It doesn't tell you that though, it locks you out and you don't realize. You then attempt 2 or 3 times, now you're locked out by both systems, you contact the fraud team says, yeah, you're grand, but you're still locked out because you've been locked out by the rate limiting. And they both work, but we're stuck. Our edges between the edges aren't good. Create an interaction matrix and see where they line up. Write property-based tests would be my number 2 recommendation. Not just ones that are turning around and saying, if this input, then do this, but say for any input that looks this shape, make sure you do this. Be specific and explicit. So if a blood sugar is less than 3.5, it should never, ever give insulin. If it's less than 4, we might have a slightly different rule for the complex diabetes side. But that's what we're going with. Use hypotheses, use fast check, whatever language you're using will help you generate millions of randomized tests that you can run overnight and see what happens when those edge cases clash. Think about chaos engineering. I wouldn't use it in all of my infrastructure, but I would certainly start to use it more in my business logic. Turn around and say, okay, well, I have these flags. Let's start to set them all to random patterns. And let's see what happens when these edge cases clash. Again, set it to run overnight. Let it go. See what it comes up with. And then figure out what happens when all these individual parts are flagging up things in combinations that we maybe didn't think about before. Document explicitly what must never happen. Create a file, call it invariants.txt or whatever it is you want to do, and make sure that it's accessible for your teams. And then write a test bench that is separate from your normal tests that clearly documents exactly what must happen and what must never happen. This user must never see this user's data. Blood sugar must never get insulin if less than 4. Make it explicit, and then make sure they always run every time, and when they go wrong, sends off alarm bells that flags to everyone. Page senior engineer and get them in here now. For machine learning systems specifically, make sure we're testing not just the accuracy of it, 95% is great, but make sure we have the decision boundaries outlined and test around those specifically. If we have a credit score that's turning around and saying, okay, this person's got 699 this time, we feed it in again, it's 95% accurate, so we get 700 this time. That's a life-changing decision, because you can't get a loan with 699. So can you justify it? Do you have tests around that? Have you accounted for it the entire way through? Make sure we're writing these tests that sit right on the decision threshold, verifying then that our behaviour is stable and explainable. We're pretty good at building observability into our systems. Why not write it into our business logic too, so that it turns around and alerts our users with metrics, traces, dashboards, and turns around and says, well, actually, here's some edge cases that have hit that we never thought could hit before. Send the alert. Let somebody else figure out what's there, and then make it run. And when we are starting to bring machine learning into what we're doing, make sure that we are feeding in slowly. Make sure that we're implementing feature flag controls for these rule interactions. Because what we want to do is not just have the ability to gradually roll out and to roll back, but to turn around and say, well, this edge case works great, and this one works great, and the two agents seem to understand what's going on, but we just want to check with 5% of our users first that the two work together and are bringing success. And if one starts to go wrong, we've got a small rollback we can make about turning off that specific problematic edge case rather than denying all of them. Number 8, use your threat model. And if you don't have one, why not? It doesn't just give you an up-to-date living document that provides you with insight into your system as to where your vulnerable data is going to be and the defenses that you have around it. It's also showing you on this boundary what the vulnerability is and how much you value the data. And where you value the data, you should be putting effort into verifying that it's as safe as you can possibly make it, and any edges that lie around those boundaries should be tested further. It will also remind you of how the data flows through your application, the processes that it's discovering along the way, and might help you highlight things that we haven't tested for properly before. 9, get to know all the people and what all the people need. Whether you're going to your user and spending more time with them, like the engineer shaking the hand of the diabetic, get to know the weird things that they see that aren't on your requirements and start to put them into code. Get to know your user. Or discover as your team, whether you're senior or junior, can you turn around and say, I know how to do this, or my team don't have a clue what's going on. Listen to them, support them, get the training that's needed, build testing up to the new level that it needs to be at. And the party in the background. The robots and the people are dancing. Woo-hoo. But understand where your limits are. Understand as a result where your machine's limits are going to be, and put in the tests around those boundaries, those decisions, those edges to protect your user, to protect you, and to point your machine in the direction that it needs to go. And number 10, ask this uncomfortable question. Regardless of what your system does, would you trust it? Would you trust it with your money? Would you trust it with your freedom? Would you trust it with your health? Because increasingly that is what we're asking our users to do. We've gone from processing data to making decisions. And if the answer here is well, or maybe, or probably, or well, in most cases, then the absolute answer has to be we have not tested this system sufficiently. So what I learned is that the system can be confident at R72, but it's putting me in danger. I learned that the tests have all passed, but I'm still in danger. And I learned that the algorithm was definitely learning, but I was still, more than ever, in danger. We have automating tasks that are replacing judgment. We've got humans that are being supported and acting autonomous systems instead. How do we protect against those? So yeah, we need to keep our unit tests going. We need to be keeping our coverage metrics high. We need to be keeping those builds green. But don't confuse what's actually keeping your users safe. Test the edges between the edges. Make sure that we are testing for impact, not just for implementation and coverage. Document what must never happen and stick to it. And as a result, any designs that we have should start to become more transparent and start to suggest where overrides need to happen to protect. And make sure that you're asking yourself those hard questions. And if you trust a machine with those, shame on you. Your tests are probably passing right now, but that does not mean your users are safe. Folks, thank you very much for listening. This was documented in a blog post a couple of months ago that maybe was slightly less emotional than what I felt like I was today. So if you want to read more, check the code out. It takes you to a LinkedIn link. So you can contact me on LinkedIn through that. You can see the website. You can see some of the training we're offering around these topics as well, with more going up every couple of weeks. So check me out, connect, ask me questions, and I'm happy to answer.
Much for that, Andrew. Does anybody have a question? We have time for one. If you pop your hand up, I'll come round. Perfect.
How's it going? Main question I think is on everyone's mind is, what did the manufacturers say when you reported all this to them?
Trust the algorithm. The reality is at the moment that closed-loop technology is still a fairly new thing. The reality is when you compare diabetics who have the insanely bad control or they're just brand new to it and they're starting to learn, these systems do make a huge difference. They can bring HbA1c's down because these people are used to sitting with blood sugars at 16 and their body starts to adapt, and it's bringing them down into range. So for the majority, for now, it is making a big difference. But for the smaller amount of people that are maybe in much better control to start with, that's where the problems are really starting to appear. And my opinion would be that in 2 to 3 years' time, when the people that are badly controlled are becoming better controlled, the flaws are going to become obvious for the majority rather for the minority. There are other pumps available, there's other systems, depending on whether you're on NHS, private, how much you want to fund. So you can pay for different algorithms and see how they work in different ways. And certainly at the moment, because of what I've been through, I am researching other systems now with a much deeper understanding of the problems that are out there. And there's been a few other manufacturers that I've contacted and said, what happens when this happens, this happens, this happens? And that's where the conversation stops. Not because I've got an answer back that I didn't like, but because I'm getting no answer, which I think tells as much of a story as anything.
Say on behalf of everyone in the room, thank you so much for sharing that. It must have been very difficult, and thank you for being the person behind the system. We have a break, guys.